everybody. In this video, we're going to be talking about how to solve problems that involve multiple combinations. So take 3 deep breaths and let's make this math easy. Okay, so in our last video, we talked about the combination formula. And remember that the combination formula builds off of the permutation idea, because the permutation formula gives us the number of ways that we can choose a certain number of things from a bigger group of objects or people or whatever it is you're working with. And it's specifically when your first choice impacts your second choice, which impacts your third choice, and so on. So that's why we have that falling exponent idea. And then with combinations, we use the exact same choice tree, but the combinations apply when the order doesn't matter. So like if option A, B, C is considered to be the exact same thing as C, B, A, like if you mix around the order of the options, it doesn't make a difference, then that's where we do combinations. And we take the permutation formula and divide by the number of times that a certain group will show up duplicated in the choice tree, or like the number of times that that group was duplicated. So that's the relationship between permutations and combinations. And sometimes you'll have problems that involve multiple combinations. So for example, let's say that you're building a bouquet and you want to figure out how many ways you can build the bouquet if you need to select one color of ribbon from 6 different choices, 2 types of greenery from 5 choices, and 3 types of flowers from 4 choices. So we could calculate the number of ways that we could do each of these individual things on their own. So we could say, if I need to select one color of ribbon from 6 choices, the number of ways I could choose my ribbon would be just 6, because there's one event that's happening and I have 6 options for that one choice that I'm making, because I'm only choosing one color of ribbon. And then for the second part, the number of ways I could choose my greenery would be, since I'm choosing 2 types of greenery, I have 2 events. My first event has 5 choices, and my second event would have 4 choices, because you don't want to choose the same type of greenery twice. So like if I chose ivy, I wouldn't want to choose ivy again. I'd want to choose a different type of greenery. And then you want to ask yourself, does the order that I choose them in matter? Like if I choose ivy and then some type of grassy greenery, I don't know what that grass is called, but like if I chose it as ivy and then the grass, is that the same thing as choosing grass and then ivy? Like, can I switch around the ordering of it, or are those considered to be different things? And in the case of a bouquet, it doesn't really matter which type of greenery you choose first. It's still going to contribute to the bouquet in the same way. And so that means we need to divide by the number of times that any set of greenery shows up duplicated in the choice tree. So if I'm choosing 2 types of greenery, the number of times that any pair will show up in the choice tree is going to be 2 times 1, or 2 factorial. So to calculate this out, I go 5 times 4 is 20, 2 times 1 is 2, and when I do 20 divided by 2, I get 10 different ways that I could choose 2 types of greenery from 5 choices. And then for the flowers, the number of ways I could choose 3 flowers from 4 different choices. I'm making 3, there's 3 events because I'm choosing 3 types of flowers. The first choice has 4 options. The second choice has 3 options, and the third choice has 2 options, because I don't want to choose the same type of flower multiple times. I want to have 3 different types of flowers. And then I ask myself again, does the order that I choose them in matter? Like if I choose roses and then tulips and then daisies, is that the same, or is it different than if I chose daisies and then tulips and roses? And just like with the greenery thing, it doesn't matter what order I choose them in, it's still going to be the same 3 flowers in the bouquet. So that means that we would divide it by 3 factorial, or 3 times 2 times 1. And when we multiply those out, 4 times 3 times 2 gives me 24. 3 times 2 times 1 gives me 6. And when I divide 24 by 6, I get 4 ways that I can choose my 3 types of flowers. Now, remember, these numbers are describing the number of outcomes that are in each of these sample spaces. So the sample space for ribbon might look something like, we have like red ribbon or yellow ribbon, black ribbon, I don't know, white ribbon, and so on. But you have 6 different things in this set of your different options of the ways you could choose ribbon. And then for greenery, in this sample space, you have pairs of greenery. So maybe you have ivy and grass, and then maybe you have ivy and I don't really know very much about greenery that they put in bouquets, but maybe we'll say leaves or something. But like you have a bunch of different pairs of different types of greenery that you could choose. And there's 10 of these pairs in that sample space. And then in the flowers set, you have 4 different sets of like triples of flowers. So you might have like roses, tulips, and daisies. Or you might have roses, tulips, and I was going to say daffodils, but daffodils starts with a D. So let's do maybe, I don't know, wisteria or something like that. And then maybe you have tulips, wisteria, and daisies. Or roses, I think wisteria and daisies is the other one I don't have yet. And so those would be the 4 items in that sample space. And again, you could rearrange these letters in between, like in the sets of 3, because the order doesn't matter. But those would be the 4 unique groups of 3 types of flowers that you could choose. So we have these 3 different sample spaces of ways that we could choose each of the individual parts of the bouquet. But when you're actually figuring out the number of ways you could build the whole bouquet, you have to keep in mind that you could pair any one of these options in each of the sample spaces with any of the options from the other ones. So it's kind of like you have another choice tree that describes the entire bouquet. And in this other choice tree, you have like 6 branches with the different types of ribbons. So you could choose red, yellow, blue, white, etc., all the different types of ribbon. And then branching off from the types of ribbon, you have all of the 10 different ways you could choose your greenery. So you could choose ivy and grass, or you could choose ivy and leaves, or whatever other combinations of 2 pairs of greenery that you could have. And then branching off of each of those pairs of greenery, you have 4 sets of 3 flowers. So you could have roses, tulips, and daffodils, or roses, tulips, and wisteria, or tulips, wisteria, and daffodils, or roses, wisteria, and daffodils. And that choice tree represents the number of ways you could build a bouquet, because it's like you have to choose a ribbon and greenery and flowers. And there's going to be a lot of different ways you could do that. And the way that you calculate that for the entire bouquet is you take your 6 options for choosing your ribbon, multiply by your 10 options for choosing your greenery, and your 4 options for choosing your flowers, and that would be your total number of ways you could do your bouquet. So I think that works out to 240 unique ways that you could build a bouquet. And you don't have to divide by anything in this case, because basically like these choices that you're making are from separate groups of things, like you're choosing from ribbon versus greenery versus flowers. The dividing only happens when you are choosing from the same group, and the things that you choose from the group are listed in different orders. So the general formula for a multiple combination situation is if you're choosing a bunch of different objects from larger groups of other objects, where, like in this case, I had J represent the number of items that you're choosing from the subgroup M, and K is the number of things you're choosing from the subgroup N, and L is the number of items coming from the subgroup O, then you basically just do a combination for each individual thing and then multiply them together. And the example we just did had 3 combinations. So that was why we had 3 numbers multiplied together. But you could also have like 5 different combinations. You know, like if you had to choose the ribbon, the greenery, the flowers, and the accents and the card or something like that, then you would have like 5 different combinations that you would multiply all together. But that's the basic idea of how to do multiple combinations. So why don't you guys try this one on your own? Pause this video and then restart it to see how I would solve it. Okay, so the correct answer on this problem is that there are 5,400 ways that you could order this pizza. So if you got the same answer as me, great. If you got a different answer, go ahead and watch the rest of this video to see how I solved this problem. Okay, so in this problem, we're asked to find how many ways you can order a pizza when you are allowed to choose the type of crust from 3 different options. You can choose 3 meats from, how many options is that? 6 different options. 2 veggies from also 6 options. And 2 cheeses from 4 options. So we have 4 different sets of choices that we're making. So we're going to have 4 combinations, and each one of those is going to have a different calculation because you have a different number of options as well as number of things that you're choosing. So for the crust calculation, we're only choosing one type of crust. So there's just going to be one event, and we have 3 options for that choice. So that would be 3. And technically, you could divide this by 1 factorial, but 1 factorial is just 1. So regardless, the number of ways that you would get the crust would be 3. There's 3 ways to choose the crust. And then for choosing your meat, we are choosing 3 meats to put on the pizza. So we have 3 choices that are happening. And the first choice has 6 different options because we could choose any of the 3 meats. And then the second choice has only 5 options because we don't want to choose the same meat twice. And then the last choice has 4 options because we don't want to choose either of the first 2 that we've already chosen. And it doesn't matter which order you choose the meat in. It's still going to, go on the pizza all at the same time. And so we would divide this by 3 factorial because 3 factorial is the number of times that any triplet of meat will show up in the choice tree, represented by the 6 times 5 times 4. So when we calculate this out, 6 times 5 is 30, times 4 gives us 120, and then 3 times 2 times 1 is 6. When we do 120 divided by 6, we get 20 different ways you could choose the meat. Then when you're choosing your veggies, we are choosing 2 veggies, so we have 2 events that are happening, and there's 6 options for our first veggie, and then 5 options for the second one because we don't want to choose the same veggie twice. And the order that we put the veggies on doesn't matter. They're all going to go on at the same time, and so we would divide this by 2 factorial. Because whether it's onions and peppers or peppers and onions, it's still the same veggies. So we divide out those duplicates, and 6 times 5 gives us 30. 2 times 1 gives us 2. And so there's 15 ways that we can choose 2 veggies from the 6 options. And then the number of ways we can choose our cheeses would be, we are choosing 2 cheeses. So again, we have 2 events. There's 4 choices for the first cheese and then 3 for the second because we don't want to have the same, like 2 of the same cheese on it. And then it doesn't matter whether you choose mozzarella then cheddar or cheddar then mozzarella. And so we're going to divide out the duplicates. And the number of duplicates is 2 times 1. And so that calculation would be 12 divided by 6, because 4 times 3 is 12. Oh, sorry, not 6. 12 divided by 2, because 2 times 1 is 2. And then that gives you the number 6 for the number of cheeses you would have. So each of these numbers are the number of ways that you could choose each individual thing from the different flavors that we were given. The number of ways that you could order the pizza is going to be the 3 ways that we could order the crust multiplied by the 20 ways you could order the meat multiplied by the 15 ways you could order the veggies multiplied by the 6 ways you could order the cheeses. And when you multiply all of these together, you end up with, let's see, 3 times 20 is 60, times 15 is 900, times 6 is 5,400. So there are 5,400 ways that you could order this pizza. And that's how you would do that problem.